So we're going to start off with that.
Well, and before we started, I just want to say thank y'all for joining us. I got a room full here at Velma Jackson High School, and we're recording this for all of our STEM students in Madison County schools at my friends Jatoria Kirksey and Angela Reed at Old Town Middle School, and Vicki Parks at Germantown High School, and Greg Morgan at Madison Middle School. So a lot of students are going to see this later, but I've got a room full here with me seeing this live.
Great.
You have the ability to share screen now, so anything you want to show to start off, you can have the floor. And we do have some, and I already got some great questions that are actually going to be pretty tough to answer here at the end. So I'm looking forward to hearing y'all's answers on these.
Great. So good morning. My name is Kurt Bieto, and I'm the Senior Manager for Systems Engineering here at the Nissan plant. And joining me is Alan Kennedy. And Alan is the Senior Manager for Process Engineering. And we have one of our engineers, Camille Newell, and Megan Gillespie is our other engineer. So with that, we're going to roll into a video, if everything goes well, and show you a little about Nissan. Can you hear that, Greg?
I cannot. I see it, but I cannot hear it.
Okay, that's why I thought I'd. I don't know where to get that control. I guess I got to stop the share. I don't have an option to do that. Yeah. I'll tell you what, Greg, we're gonna skip the video. We'll go right into questions.
Well, I was gonna let you guys talk a little bit about what all the systems engineers and the engineers do there, because I think it's I think there's a lot of misunderstanding and a lot of assumptions of what all you guys do at the plant. Obviously, there is a lot of manpower, but there also is a lot of mechanical power as well. I've been to the plant, seen the robots, seen the machines, and obviously it's not just people working hands-on. There's a lot of maintenance and a lot of maintaining and a lot of programming and a lot of troubleshooting on the machines that make machines, as I like to say. So what type of background and what type of jobs go into that as far as the day-to-day of the engineers at the Nissan plant?
Sure. Alan, why don't you talk about what process engineers do?
Okay. You want to mute?
Yep.
Okay. Okay. So what kind of backgrounds do we require? Well, one of the things that we require certainly is to have a good understanding of how things work in terms of machines. We typically hire engineering graduates. We also hire those with backgrounds in industrial systems and technology. We have some other fields that we bring in as well. Anybody kind of with a science background that has a good understanding of mechanics and, like I mentioned, how things move and how they work. There are different elements that are, I guess, more emphasized in different sections of the plant, where my team works in the trim and chassis side. We have the what you might call the finished portion of the vehicle, all of the things that customers usually touch, right? So the seats and the steering wheel and all the cockpit, all of those elements, as well as the finishing touches on the exterior of the vehicle. So your bumpers, your glass and so forth. But there are other portions of the process in the plant before it ever gets to trim and chassis. We have stamping, where you actually take coils of metal and you stamp out different shapes. Imagine stamping out door panels or stamping out body side panels, much like you do when you're making Christmas cookies, but basically on a very large scale. Those panels are then all connected and joined together in the body shop, and they do that through welding. And during that welding process, there are a lot of tight tolerances that are required. And so the engineers involved in those two areas have to understand a lot about how metal changes as you process it. What are the types of failure modes you can experience with changes in metal, and certainly all of the mechanisms involved with getting those pieces to stay in place as you weld them. So on the videos you typically see where there are robots moving around and sparks are flying and all that type of thing, that's the body shop portion of an assembly plant. And so those engineers, again, do those things. They have to maintain a high level of quality coming out of their shop, because that's the foundation on which the rest of the vehicle gets built. If that doesn't go together well, we can't do a good job in the rest of the system. So after the unit is leaving the body shop, it's going into the paint shop, where all of the various joints and little seams get sealed up to make it watertight. It also receives anti-corrosion coating, which gets baked on. And then, of course, it gets whatever the ending color paint will be. And so engineers there are involved with a lot of chemical processes. Obviously, the chemical baths that the vehicles go through, there's a lot of processing of and cleaning of water. You use a lot of water in our processes. And they also need to have a good understanding of plastics, because we also in our paint shop facilities mold plastics. So the bumpers, the front and rear bumpers, we mold those here at the plant. The step rail, as you might think of when you step into the vehicle, the piece that goes right under the doorway, we mold those in plastic and make those here as well. And there's some other pieces we make as well. So all of those items are done in paint shop, and those engineers need to understand how plastics flow, how much can they be heated and cooled, and how fast do you need to do that. Kind of like, again, back to that analogy, if you've got the cookie cutter and stamping, here you basically have a baking shop where you're cooking up plastics and getting the right recipe so that it comes out the same every time that you do it. So all of those things together make up a good vehicle, and the work that the engineers and technologists and others are doing to keep that going every day. Lots of math involved in that, keeping track of statistical data that the machines are giving us, and the measurements from those vehicles are giving us, and then making sense of all of that, actually using a lot of geometry and trigonometry to figure out things like gaps and flush and the fit and finish of the vehicle. And then all the way at the end, when the vehicle is finished and complete and rolls off the line, we have to drive every vehicle to make sure that all of the systems work. So the electrical systems that are in the vehicle, all of the braking and fuel systems are working, and things like the Wind noise and water leaks are confirmed. So we don't want to ship anything to a customer that isn't just right and doesn't meet the performance requirements. So there are also engineers on the far end of the plant in the quality group that do things like confirm customer performance requirements. For instance, like the driving characteristics. You may think about the vehicle being able to go in a straight line without much input from the driver. So steering off center is something that we look at. We want to control the alignment of the vehicle very carefully. We have lots of new systems now that tell you what's going on with your vehicle, like when you have a vehicle behind you that's about to come in your lane. So we have to test all of those things. So there are engineers involved in figuring out how to set up the test equipment, how to properly confirm all of the diagnostic systems that are in the vehicle, and then to regularly confirm that we're staying within the parameters that a customer would expect. So something as simple as you go up to your vehicle and you close the door. Well, how hard do you have to push to get the door to close? That's something that we look at and try to balance and make sure that, every vehicle is meeting the same target.
Yeah.
So that lots of different ways that engineers get involved, and they're used in lots of different skill sets. And some of those you learn once you get here, but many of those have common themes, and math is a common theme, and problem solving is a common theme.
Yeah, and I know recently the Titan did have a model, it had a model change. So I know that was a whole.
Oh, Camille, why don't you talk to us about what a safety engineer does?
Yeah.
Greg, were you going to say something else?
No, I was just asking about, I know the Titan did have a model change recently. So I know that after you got that system down pat, you had to go through a whole new process to make new plates, new plastic systems, new wiring harnesses. So I'm sure after that process got streamlined, then Nissan wants to change the model, and then you got to do it all over again.
Oh yeah, it's an ever-changing system, which is kind of part of the fun, right? So like me, I get bored very, very easily. So I like a new stimulus every day, talking to new people, learning new things. And my role, I'm a process engineer. I did come from safety engineering, which is also a lot of fun because you get to work with a lot of different groups and you feel like you're making a positive difference. You're helping the people on the line. They say, thank you for this improvement or thank you for that improvement. So that's a lot of fun. You kind of are in the health field, but you're also in the manufacturing world, which is really technical, and you're learning new things every day. But now I'm in process engineering. It's got some safety components to it. It's definitely got some math components to it. But basically, I'm just problem solving different issues every day. And that could mean working with the plastics group, working with the engine group, working with the body shop group, working with the oils and transmission. It's all over the place. It's a lot of fun because I work in trim and chassis, which means, like he said, it's a completed vehicle just about. So it could be an issue related to the trim and chassis plant and how a technician is putting in a part, or it could be related to a part that we get in China. And then you have to get a translator involved and work with other groups and things like that. So it's very cool. It's very fun. It's very exciting. I'll say, fortunately, I don't have to do a ton of math. I do have to do some math, but not a whole lot. Most of my problem solving is observational. So really it just takes a lot of, just common sense, to be honest. People who have common sense and people who are going to push for the right solution and just keep pushing and moving forward. You're going to get told no a lot. And you just have to basically act like you didn't hear it and keep going and give a lot of data and a lot of reasoning. Basically, give them every piece of evidence to show them. You're kind of like a lawyer in a way, a lawyer that they're wrong, you're right, and here's what it's going to take to fix it. And that's always a challenge, but a very fun challenge for me. So that's pretty much my job in a nutshell.
Yeah. And
Thanks, Camille.
and
And Megan, why don't you talk a little about what a design engineer does with building a vehicle?
Can you hear me now?
I can.
Okay. So with the design engineering, basically, it's basically a lot of harness design. So you would have to have like a lot of background in electrical engineering, like with circuits, not so much as programming, but a lot of circuits. And what happens is we'll design these systems that goes into the vehicle. So it makes everything in the vehicle communicate. I was in charge of in my old job, I was in charge of the engine harnesses, chassis PDC, cab light. So basically just designing all that to make the lights in the car light up. There are times when we'll have like these bills to make sure that everything works. And if, say for instance, like something is wrong with the harness, we'll have to troubleshoot that. We work a lot with the people in the plant, the technicians and stuff like that. So really just communicating and just trying to get the job done like that.
That's cool because we're actually doing, we've actually been working on a circuit board here in class. So it's cool. All that stuff works together. I mean, we're obviously on a small circuit board, but it is, I think, the thing about how those circuits have to, they all have to work together to have one end process.
Right. Yeah, exactly.
Now, and again, I'm a manufacturing novice, but, and obviously, and honestly, I'm a STEM novice, engineering novice as well. But all these areas working together, one thing that we see these students is that if they don't get it right the first time, they want to quit, and it's just too hard. So in the engineering field, no matter what field of engineering you're in, how often do you actually get it right the very first time?
Very, very rarely. Sometimes you do, some people do have a natural intuition, and really I think that they're just, very intelligent and their brain is processing things quicker than their conscious can realize it. But for the most part, you have to go through a checklist of, okay, I've looked at this, I've looked at that. It's very methodic. But when you do that, you will eventually come to the right solution. And sometimes your gut is right, sometimes it's wrong. But for you to say, hey, this is the issue, you have to basically validate it. You can't get discouraged on that first time. And honestly, that first time, if you get it right, there's no reward in that. After, trying and trying and trying, and finally you get it. Oh my gosh, there's really no better feeling than finally achieving your goal or finally proving out your point. And we do that all the time here at Nissan. It's definitely one of the most rewarding parts of the job.
I'm doing all right, Mark. You all right, man? That's the best part.
And then also obviously, and you guys are just a small portion of what all goes into manufacturing a vehicle. From what you said, not only does it take being at least knowledgeable multiple materials, multiple areas of chemicals, multiple areas of robotics, and multiple areas of mechanical parts. How or what type of background are you guys looking for? As far as engineering, are you guys looking for more with somebody with the technical or the book knowledge, or somebody that's had a little bit of the hands-on, because obviously Mississippi State, Jackson State, now they have these engineering programs. Are you guys looking more for somebody that's got the certificates from the Hines or the Holmes and maybe had a little bit of experience on the engineering side, or is it more of we want the 4-year degrees?
Yeah, I can take that one. So actually, we hire them all. we get on both ends of that. So I mentioned earlier the different types of areas that we utilize technical people in, and we won't forget about the fact that we also have maintenance as a part of what we do, and within the maintenance areas, and even in some of the parts inspection areas and some of the vehicle testing areas, we look for technical people who, may have gone through community college. They have some background there, and that's very useful. So it's not just that we need engineers. Technologists are also folks that we need, and we utilize them in a lot of different roles and on some key areas. I mentioned maintenance and vehicle testing, but there's also in our metrology lab, which is basically a dimensional evaluation lab. Lots of detailed things go on in there, and those are mostly populated by folks who have, in some cases, a high school diploma, in other cases, a 2-year degree, and in some cases, a 4-year degree. So they are support teams that assist the engineering teams with understanding the root of what some of the issues may be, and then helping to figure out what possible solutions may be as well. So I'm glad you brought that up, because it's not just about going and getting an engineering degree and even having the experience in engineering, but having a technical background, regardless of where it may come from. You may find that there's a place for you in the automotive industry, working in a assembly plant, or even in some of the other areas in supply chain and some of the other support functions.
Yeah.
So Megan, what kind of degree do you have?
I have an electrical engineering degree from Mississippi State.
Cool.
And Camille?
I have an undergraduate in pre-physical therapy and medicine, and then a graduate degree in safety engineering, and I'm working in process engineering. So like I said, I think it's most important to have common sense and basically show motivation. But even though Megan and I have degrees, like Alan was saying, there's a very large variety here in the plant.
Yeah, and I know you guys provide, obviously you guys are one of the top employers in the state, especially in the area. But, I hear kids all the time just say, oh, I'm gonna go work at Nissan because they think it's easy. But, one thing you have to, I think they need to realize is that not only is the engineering part, obviously the safety part, and then you got to be safe with the chemicals. But at the end of the day, you got to be able to produce a quality product and stay under budget. You don't just have an unlimited amount of money to have always the most technologically advanced stuff. You have to be able to make work with what you have. And even though you do have, I've been to the plant, I've seen some of the stuff you guys use, and it is pretty dang cool, but you don't just have an unlimited budget to have that stuff all the time. You had to be able to stay efficient and stay on top of the capabilities of your machines.
And Greg, you're right on target. My undergraduate degree is as an electrical engineer. So I work with all the computers and power and network and all that kind of stuff. But I also went and got my master's degree in business, so I can keep track of how much it costs and learn how to manage people and achieve projects on time. So that's how I expanded my background. Alan, what's yours?
Yeah, sure. I have a undergraduate degree in mechanical engineering from Mississippi State. I also have a master's degree in mechanical engineering from North Carolina State.
Cool. And
I also have a master's in arts and communication from Saginaw Valley State. So I have a multiple degrees there. So that's not necessary to certainly work in this industry, but it makes you certainly more flexible to what kind of assignments you can take, what kind of areas you can go into, and certainly what sort of challenges you might face, because you're able to think in a broad way, and certainly communicate better with those who need to understand technical items being explained in a non-technical way.
Yeah, and before I get to the students' questions,
What else you got for questions?
I have some from the students, but I have one more before we get to the students' questions. Is obviously with Mississippi State and now Jackson State getting more into the engineering game, and as well as Hines of Holmes with their engineering programs, what type of partnerships are you having with those schools? Because obviously you want the graduates to stay in Mississippi. So if somebody wants to go to Mississippi State or Jackson State, Hines, Holmes, or any of those areas, what is Nissan doing to keep those graduates in the state of Mississippi?
So, Greg, we work with Holmes Community College for fork truck training and robotics training and things like that at the technologist level. We have a job fair every year where the local colleges come in and talk with our people about improving their skills. But then we also, interview with, the big schools in the state with Mississippi State, Ole Miss, and USM. And the other one that is a newcomer into the engineering field is Mississippi College now has an engineering program.
Yep.
So, we've had a student there in our internship program. And when she graduated, we gave her an offer, but she decided to go with C-Spire. So, a lot of challenges for, keeping people in state because right now there are more jobs than there are people who have those skill sets. So there's a lot of competition and they talk about everybody, moving around. That's one of the challenges. So you really try to create a culture where, you can attract people, but then once they're here, you keep them motivated and challenged in what they do. Because really engineers are problem solvers and they're looking for a good challenge. And Camille, have you run out of challenges to tackle every day coming in yet?
No, I don't think that'll ever happen.
And then I forgot, the other teachers will be upset about it and ask this, is obviously the students all know TikTok and Snapchat and that's cool and all, but how important is having those technology skills? Because what type of technology do you guys work with every day? And I know it's constantly changing, but what's some of the technology that you guys work with?
So let me tell you about the very first day when you come to work for me in my department. I give you a computer that came right out of the box and I tell you, figure out how to make it work.
Wow.
The engineer has to figure out how to get it working and figure out where the operating system is, how to load it, to get it connected to the network, to get all the right software. Because my department as the systems department is the last stop. If somebody can't figure out how to do it, they come to us and we have to figure out how to make it work. So on day one, I'm challenging you and setting the tone that you need to figure out how to make this work. So as Camille said earlier, we don't always get it right the first time, but people come to us to learn how, because they have a problem, they don't know how to solve it. So whether you're a mechanical engineer, an electrical engineer, a chemical engineer, a safety engineer, they're coming to you to, solve a problem that they don't have the technical skill sets to do. So the answer to your question is on the computer side, we're working with the, Windows operating system on the client side, but I'm working with Server 2019 on the application side. On the network side, I've got Cisco network switches. So I'm looking for people with CCNA certifications. And then Microsoft Certified Systems Engineer certifications. Because at the end of the day, yes, you're looking for skills that people have. And, yes, if you have an engineering degree, it'll teach you to solve problems. But the more skills that people bring to the table, the more qualified and the more likely you are to, be attracted to hiring that candidate.
Yeah, and that leads us into our first question. And this is a great question. This is Brian McMurtry, and he's in 10th grade. And he asked, what is a required skill that you guys have that most people would not think of?
I'll jump in there. I would say negotiation. You have to be a good negotiator to be effective in implementing change. So when I was in safety, especially, we would have to try to convince manufacturing to buy this $20,000 piece of equipment because it was going to make it safer for the technicians, but we didn't have a budget. So we would have to try to put together a cost benefits analysis, appeal to their sense of humanity and things like that. So negotiation is a very important skill in my role at the plant, and it's definitely not something people think of very often.
Oh, yeah. This question is from Alonzo Johnson, and he's in 9th grade. And he asked, if a machine goes down, what is the practical time frame to have it back up and running?
I always figure it costs $10,000 a minute to have, downtime. Okay. What? That's the number I use. So the longer it's down, the more expensive it is.
Wow.
So yes, the answer to his question is we talk about mean time to repair. MTTR is the industry standard that we track how long it takes from when something stopped running to getting it running. As the systems engineering department, we notify people that the machine is not running so they can respond quickly and get there and start to begin to resolve that issue. So ideally, we like to have it up and running in 3 to 5 minutes. Sometimes it takes 20 minutes and sometimes it takes an hour. So now do the math. If you're down for an hour at 60 minutes at $10,000 a minute, you've
That's
got
like
over $500,000
$80.
of lost, profit and revenue.
Holy shnikes. That is a lot of money. That's mind blowing, but it really shows how important it is to be able to work on that new technology, and it's always changing. Now, this is a great question. This is Reginald Cooper. He's in 10th grade, and he asked, how do you think the vehicle manufacturing field with changes to fully electronic cars will change your jobs in the future?
So here's what I can tell you. Nissan has been building electric vehicles for 10 years. We started in 2012 with the Nissan Leaf here in the United States. So it's nothing new, to Nissan as we look at electrification. A lot of the other car manufacturers have, joined in since then. What I can tell you is you no longer have an internal combustion engine, okay? So you don't have a fuel system, you don't have, gas, but you still have four wheels, you have a seat, cockpit, all the interior functions. The difference is now that space that you use for the engine becomes, storage space, and the batteries now have to get stored someplace else. So they typically go either where the fuel tank was, or some other, competitors have looked at putting skids underneath that, contain all the batteries. Tesla stores them everywhere they can inside the vehicle, and they got them glued all over the place in there to get the range that they have. So everybody's got a little different way to go about it, but really what you're talking about is, I think as the industry progresses, I think you're going to see that the motors are going to be in the wheels themselves. So instead of having a motor and a transmission and a mechanical linkage, I think you're going to see, as we move forward, you're going to have an electric motor inside of each wheel, and you're going to, control it. I think that's the future as we move forward, as people with different ideas and different visions take the challenges that electrification, have, and the opportunities it presents, and change how the vehicles are designed.
Wow. This is Kamiria Smith, and she's in 9th grade, and she asked, if someone tells you they want to work for your company, but you obviously know they're not a hard worker, how quick would you be able to tell that they are not good for the job?
Megan, what do you think?
I think instantly, because when you're working in Nissan, it's kind of like an emergency room. So you need to be a hard worker, accept challenges. It's not difficult. It can be if you're not a hard worker. So yeah, please don't have that mindset. You probably won't last.
This is Trevion Blackman. He's also in 9th grade, and he asked, what is the biggest challenge that you guys face every day?
There's only 24 hours in the day.
That would be for me too. This is Jaheim Banks, and he's also in 9th grade, and he asked, why did you choose to work for Nissan?
Camille.
Yeah, I'll go first. Nissan is a well-known company. I came out of college. I'm just going to be completely dead honest with you guys. I came out of college and got a few offers, and Nissan was the only one where everybody's going to know what Nissan is. Everybody's going to know where you work. So I knew it'd be a great resume builder. They made me an offer that I was like, oh, fresh out of college, heck yeah, I'll take this job. It was significantly more than the other offers. And then I got here thinking, because I'm not from Mississippi, I got here thinking, okay, I'll put in some time and then check out some of the other industries. But I love it. The diversity here is amazing. The team mindset is really good. It's getting better and better every year from what I've seen the 6 years I've been here. And, we actually care about our technicians. We remember that they're people and not, just a workforce. So, I came in really for the name and for the money, but I stayed for the people for sure.
That's awesome.
Megan, why do you want to work for Nissan?
And Nissan is very challenging. I'm like Camille. I'm the type of person I get bored easily. So working in Nissan is always a challenge every day. The team is great. If you need to know something, if you don't know something, there's always resources. You're not going to be left alone. And it's just a good place to work for. The opportunities are limitless.
That's awesome.
Alan, what do you got?
Okay, so I've worked at a couple of different places. So I've used to work for General Motors up in Michigan, and ended up working also for General Motors out in Kansas. So I actually came to Nissan as a way to get out of the cold. I felt I was done doing ice scraping and snow shoveling. So this was located in the South, and seriously, it's a major player in the automotive market. We've been around for over 100 years. So a lot of different things have been done in that time within the company, and we keep innovating in different ways. So that was exciting to me, and joining a team in a different place, and with a lot of flexibility in the plant was also something I found attractive. In many of the other plants I was in before, typically you may have one or two models at a time. Here in Canton, at one time we had basically 8 different vehicle models. We're currently at 3, but we look to do some expansion as we continue to grow, and Nissan continues to develop new models, and hopefully they'll arrive here in Canton and we can build those. So it's always a good way to make an impact, and certainly I hope I've been able to do that while I've been here. So
That's awesome. Well,
Yeah.
We're
almost out of time. We're almost out of time, Kurt, and I appreciate all you guys joining us. But before we go, obviously, with it being Black History Month, and I've got a room full here of young Black kids, Mississippi, right down the street, and I just want to ask, how important is the representation and the diversity that they can be a part of at not just Nissan, but in all of the engineering fields, and all the engineering jobs that are here locally?
Camille, go ahead.
yeah.
Okay, I'll go ahead. I mean, representation is key, right? I don't think that a lot of demographic groups really get that more than Black people. It's super important. Diversity is proven to bring greater ideas, more diversity in ideas itself, and that if you have good leadership, then the group that has greater diversity is going to be the one that flourishes. So I think it's very important, and STEM is a field where the diversity is getting better, but also women-wise, it's not necessarily increasing at the rate of other fields. So I think a lot of women go into fields where they feel like they can help people. So like teachers, nursing, things like that, things that make you feel better about yourself or help out the community. But people don't realize that at a manufacturing plant of 6,000 people or things like that, you're helping people every day. So I think it's very important. It's very important to have representation. We have plenty of synergy groups here that I'm part of the multicultural business synergy team, where we help push statistics and educate people on that. And I'll just leave you guys with this, when you're a kid and you see people like you succeeding, it gives you the self-esteem to do the same thing. So don't you want to be that for other people? So that's part of why I'm part of these groups and things like this. And hopefully the kids in your class will do the same thing in 5-10